Welcome to 2-Minute Science Lesson with Mr. Larson. Today we're going to talk about waves. There are two different types of waves. We have our transverse waves and we have our longitudinal waves. Transverse waves are what you commonly think of when you think of wavy water or a wave in a crowd where everybody stands up and throws their arms up. Okay, this type of wave tends to look something like this. The other type of wave is called a longitudinal wave. Longitudinal wave is more of a compression wave. If you think about this, if everybody's in a line and they're really packed together, and then think of somebody in the back pushing somebody in the line, what's going to happen is everybody's going to be bumping into each other and all going to fall down the line as that energy passes through the line. That's a longitudinal wave. That's very similar to how our voice works when we talk. That's how sound travels. The air molecules hit other air molecules, which cause them to move, and we call these compressions, and then when it spreads out, that's called a rarefaction. And this is going to look, if you use a slinky, kind of like this. And that's just how that energy is being traveled. Now, we have different parts of a wave. We have the crest and the trough. The crest is going to be the top of a wave, and the trough is going to be the bottom of a wave. The resting point from where there was no wave, that's called the normal. When you search a wave moving, we actually use the term called amplitude to explain how far away the crest is to that normal or the trough is to that normal. And that distance is always going to be the same between the normal to the crest and the normal to the trough. It's going to be the same amount. Okay? And then you have wavelengths. That's the distance between crest to crest on a wave, and that's often going to use more energy, and that's just measuring that wavelength. Thank you. Have a great day.